Human civilization operates as a high-entropy machine, requiring constant caloric and mechanical inputs to maintain its state of relative order. When these inputs cease, the second law of thermodynamics asserts itself, beginning with the global electrical grid. This timeline tracks the estimated failure intervals of primary systems on a logarithmic scale. It maps the collapse from the initial seconds of zero input out to the first 100 hours. Modern power infrastructure requires precise sub-second balancing between generation and load. Without human dispatchers to isolate localized faults, automated systems attempt to modulate voltage until cascading disruptions cause a total blackout within 2 to 12 hours. Fossil fuel power plants depend on continuous mechanical feeding. Without operators, the automated conveyors and pulverizers exhaust their active fuel stockpiles or mechanically jam within 48 hours. Hydroelectric facilities are the final localized power sources to remain active. The turbines in structures like the Hoover Dam can technically continue spinning for months, generating power until biological growth clogs the cooling intakes or the bearings fail from a lack of lubrication. The modern built environment is entirely dependent on continuous active management. Without it, the primary infrastructure for power and fuel ceases to function in less than 2 days. Grid failure immediately stops electrical pumping in municipal water systems. This causes a total pressure drop in water mains and the cessation of all automated fire suppression. Many major cities rely on mechanical intervention to manage the local water table. In New York City, 13 million gallons of groundwater must be pumped daily to keep subterranean transit networks viable. Within 36 hours of a power loss, the primary pumps stop. Groundwater begins to fill the subway tunnels, overwhelming the subterranean infrastructure. This initiates a broader hydrological reequilibration. Historic buried streams reclaim their original courses, eroding the soil beneath roadbeds and foundations, leading to massive sinkholes and differential settlement. Subterranean erosion and structural inundation destabilize major urban centers long before traditional atmospheric decay begins to compromise their skylines. The planet's 440 commercial nuclear reactors are engineered with multi-layered fail-safe mechanisms designed to prevent a runaway fission reaction in the event of abandonment. When sensors detect a loss of grid power, an automated scram is initiated. Neutron-absorbing control rods are inserted into the core via gravity or pneumatic pressure, halting the fission chain reaction within seconds. Stopping the chain reaction does not stop the decay heat generated by the radioactive breakdown of fission products. This represents roughly 7% of the reactor's full thermal power and must be actively removed by circulating coolant. Backup diesel generators provide cooling power for 10 to 14 days until their fuel is exhausted. Once the pumps stop, the coolant boils away, and the zirconium cladding on the fuel rods reacts with steam, allowing hydrogen gas to accumulate to explosive levels. Spent fuel pools pose a more severe threat. Once the shielding water evaporates, the densely packed fuel rods can ignite in the air, lofting isotopes like cesium-137 and strontium-90 into the stratosphere. While autonomous fail-safes manage the immediate shutdown, the lack of long-term cooling results in localized radioactive exclusion zones across the globe. The timeline axis shifts to 1,000 years to track the structural decay of the built environment. In the absence of maintenance, water ingress is the primary driver of architectural destruction. Glass skyscrapers are remarkably fragile. Water seeps into silical sealants, expands during the freeze-thaw cycle, and pops the tempered glass panels, exposing interiors to the elements. Older masonry-clad structures, like the Empire State Building, are expected to outlast modern glass towers. Their thick stone exteriors provide a robust barrier against moisture. Modern infrastructure is destroyed by carbonation. Atmospheric CO2 and water penetrate reinforced concrete, lowering its pH. As the internal rebar rusts, it expands, exerting thousands of pounds of pressure that causes the concrete to spall, eventually compromising the building's load-bearing capacity. Modern architecture's reliance on complex internal tension makes it more ephemeral in the geological record than primitive stone. High-pressure and cryogenic storage systems fail once automated refrigeration systems lose power. Internal temperatures and pressures rise until safety disks rupture, venting industrial chemicals into the atmosphere. These toxic plumes create localized zones where vegetation and wildlife are incinerated or poisoned by corrosive gases, mirroring the effects of historical industrial disasters. The withdrawal of human management triggers ecological release. Flora and fauna rapidly expand into the void left by civilization, exploiting the sudden absence of chemical maintenance. Urban succession follows a predictable pattern. Ruderal plants colonize cracked asphalt, followed by pioneer forests whose climbing vines trap moisture, accelerating structural decay. Domesticated species undergo a brutal evolutionary culling. Feral dogs revert to a generalized, medium-sized phenotype and form social packs, establishing themselves as mid-tier predators. Specialized microbiota metabolize leaking hydrocarbons, while biological weathering overruns the ruins of the technosphere. This timeline maps the recovery of the atmosphere over 10,000 years. The Earth's atmosphere scrubs pollutants in stages based on their chemical stability. Rainfall washes aerosols and soot from the sky within weeks. This increases atmospheric clarity, but causes a temporary warming pulse as more solar radiation reaches the Earth's surface without the reflective cover of industrial particulates. Methane concentrations return to pre-industrial levels within decades, but synthetic fluorinated gases are far more persistent. Sulfur hexafluoride, or SF6, has an atmospheric lifetime of 3,200 years and over 24,000 times the warming potential of CO2. SF6 lacks natural biological or chemical sinks on Earth. Every kilogram leaked during the final days of human activity will continue to trap heat for hundreds of generations as a permanent adjustment to the planet's energy balance. Long after the last skyscraper has collapsed, these invisible chemical alterations will continue to dictate the Earth's climate. In deep geological time, the entire human epoch is compressed into a single sedimentary layer of rock. Geologists identify epochs using a golden spike, a globally identifiable marker in the strata. For the Anthropocene, this marker is an unambiguous radioactive signature. Atmospheric nuclear testing in the mid-20th century dispersed plutonium-239 globally. Because this isotope does not occur naturally, its presence in sediment provides a precise marker for the human geological era. Strata from this era will contain technofossils. Humanity has produced 500 million tons of pure aluminum metal, which is virtually non-existent in nature. Its corrosion will leave highly unnatural mineralized imprints in the future lithosphere. The industrial broiler chicken will be the most abundant avian fossil in history. These remains show evidence of extreme genetic selection, fast growth rates, and a global distribution mirroring the human supply chain. The human presence on Earth will be reduced to a geochemical anomaly characterized by artificial isotopes and strange malformed bones trapped between layers of ancient rock. Benthic polymers like PET plastics accumulate in deep ocean silt, where they are insulated from ultraviolet light and can persist for millennia. Over millions of years, geological heat and pressure carbonize these buried plastics, converting them into brittle, carbon-rich films that preserve the detailed structure of original artifacts in stone. In 5 billion years, the Sun will expand into a red giant and incinerate the Earth. The last trace of the Anthropocene, the aluminum imprints, the radioactive spikes, and the carbonized plastics will be vaporized. The human era represents a hyper-intense thermodynamic flaring that the Earth will fold into its 4.5 billion-year evolutionary narrative. The biosphere and lithosphere will assimilate the legacy of the technosphere, reclaiming the surface as a wild and indifferent paradise.